Dear students, up to this we have discussed several discrete distributions named as binomial distribution and Poisson distribution. Discrete distribution means the random variable x took only integer values in those two distributions. In today's lecture, I'm starting a continuous distribution, means random variable may take value or values in any range, and we are starting with all important continuous distribution, the popular normal distribution. In today's lecture I will discuss several important theoretical concepts of normal distribution. As you can see, probability distribution function, in short PDF, of normal distribution is given as fx equals to 1 upon sigma into root 2 pi multiplied with e power minus half x minus mu upon sigma whole square. And values of x, especially random variable x, are in between minus infinite to infinite. That means x may take any real value in that range. X may be any real value. That simply means it's a continuous kind of distribution which I was discussing just before in the previous slide. And mu is also any real number, and sigma is a positive real number as sigma greater than 0. And in this particular PDF, mu and sigma are nothing but mean of this normal variable capital X equals to X, that is mean of the distribution, and sigma is standard deviation SD of this distribution. Here we have one more special notation to define a normal distribution. Capital X is approximately equals to capital N mu sigma. That simply means X is normally distributed with parameter mu and sigma, means with mean and standard deviation. Let's talk over several important theoretical features of normal distribution. As in previous slide, I told you that mean of this distribution is given as mu and standard deviation as sigma, and variance is nothing but square of standard deviation. That's why it's given as sigma square. Then the function which can generate all moments of the distribution with respect to origin, that is mgf mxt, a function of variable t, is given as e power t mu plus half t square sigma square. Then Carl Pearson's beta and gamma coefficients are easy to remember, at least for this particular distribution. Beta 1 is 0 and beta 2 is 3, and gamma 1, as you know, it's always equals to root of beta 1. As beta 1 is 0, so gamma 1 is also 0, and gamma 2 depends upon beta 2, is written as beta 2 minus 3, means 3 minus 3 means 0. Let's talk about these two important results, at least for calculating central moments, means moments about mean for normal distribution. There are two standard results. One is for all odd order moment, that is mu1, mu3, mu5, all odd order central moments. Then other one is for all even order central moments. As far as the odd order central moments are concerned, you can find the simplest possible result, that mu1, mu3, mu5 up to any odd order central moment is always 0 for this distribution, and even order central moment for normal distribution can be obtained using this formula mu 2n. That means if you substitute n equals to 1, it will provide you value of mu 2 as 1 into 3 into 5 up to 2n minus 3 2n minus 1 sigma power 2n. If n is 1, then n equals to 1 means that 2n minus 1 becomes 1. So it's only 1 into sigma square. If n equals to 2, then it becomes mu 4. And n equals to 2 will make this term equals to 3. So the result will come as mu 4 equals to 1 into 3 into sigma power 4. For n equals to 2, sigma 2n also becomes sigma power 2. Similarly, we can find mu 6, mu 8, etc. Any even order central moment for normal distribution. So you have to remember these two important results for expressing odd or even order central moments for normal distribution. Let's talk over several important results for normal distribution. There is one very important result written there, that median of the normal distribution equals to mod of the normal distribution, and it's also equals to mean of the normal distribution. That means all three, mean, median and mod, for normal distribution, it is the only popular distribution for which these three central measurements, mean, mod and median, are same. And as we know that mean is equals to mu, so all three are equals to mu. And then other important characteristic which is especially important for normal distribution, mean deviation about mean is 4 by 5 times of SD, standard deviation. So it's a relation between two deviations, mean deviation and standard deviation. Then we talk over standard, normal, variate. As we know that capital X equals to small x is the normal variable which we are discussing throughout this lecture, and we are correlating it with one more random variable, capital Z equals to Z is that other random variable, and small z and x, that means values of capital X and capital Z are correlated as Z equals to x minus mu upon sigma, and that standard that variable Z is known as standard normal variate, and that particular equation is extremely important for whole remaining part, that is problem section. All important problems of normal distribution depends upon this particular equation heavily, as well as in today's lecture we have discussed many theoretical results, and derivations of all those results are also important, and you can derive those all results easily using books. All the derivations are given in all standard books, so you can follow those all derivations. In fact, you must practice those all derivations, and you will see that equation will play an important role in those all derivations which we have discussed in today's lecture. So in next lecture we will discuss problem section of normal distribution.